In the world of residential construction, not all nails are created equal, and the International Residential Code knows it. In this video, we will compare and contrast common nails, box nails, and sinker nails, which are among the primary types of nails used in residential construction. We are going to shine the spotlight on the primacy of common nails in the attachment of wood structural panels to wood framing and compare them to box nails and sinker nails. The prescriptive wood nailing requirements are provided in what is known as the fastening schedule, which is the first table in section R 602.3 of the International Residential Code, or IRC. A similar table is also provided in Chapter 23 of the International Building Code, or IBC. The IBC and IRC are adopted in nearly all states and jurisdictions in the United States. The fastening schedule is one of the most important tables in prescriptive wood construction as well as engineered construction. This table provides nail fastening requirements for various framing elements in wood construction. This table or versions of this table will generally be included by designers and engineers in their drawings to guide the contractor on the fastening requirements on a particular project. The fastening requirements for the attachment of wood structural panels at the roof, floor, and walls are specified in Item 31 through Item 33 of the fastening schedule. In all cases, common nails are specified as an option for fastening, but box nails and sinker nails are scarcely mentioned. Let us look at the differences between these nail types and why builders need to keep these differences in mind when executing a project. Common nails, box nails, and sinker nails are identified by what is known as penny weight designation. The penny designation, which is denoted by the letter D that is used to identify nails in wood construction, is an old measurement system that originally indicated the price per 100 nails in England. Over time, it evolved to represent the length of the nail rather than the cost. These penny weight designations and the associated nail types, diameters, and lengths are provided in Table L4 in Appendix L of the National Design Specification for Wood Construction, or NDS, which is one of the reference standards for wood construction specified in the International Building Code. The NDS specifies penny weight designations from 6 penny or 6D to 60 penny or 60D. This table shows typical penny weights used in residential construction, where nail sizes range from 6 penny to 16 penny. Common nails and box nails have equal length but different diameters for the same penny weight designation. Sinker nails, on the other hand, are slightly shorter than common nails with the same penny weight designation. For example, 8 penny common nails and 8 penny box nails are both 2.5 inches long. However, 8 penny common nails have a larger diameter at 0.131 inches compared to 8 penny box nails at 0.113 inches. 8 penny sinker nails are slightly shorter than their common and box nails counterparts. Please note that these are not the only nail size designations used in wood construction. Another type of nail that is referenced as an option for several connections in the fastening schedule but is not shown here is the 3-inch long by 0.131-inch diameter nail. This nail type has the same length as a 10 penny common nail but with the diameter of an 8 penny common nail. As we pointed out when looking at the fastening schedule for the attachment requirements for wood sheathing, the tables allow common nails to be used for the attachment of the wood structural panels to the studs. However, the same tables do not include box nails and sinker nails of the same size designation as the common nails in the list of options for the attachment of sheathing to the wall studs. In other words, where 6 penny common nails are specified, 6 penny box or sinker nails are not specified. Similarly, where 8 penny common nails are specified, 8 penny box or sinker nails are not specified. Please note that we are only talking about the standard smooth shank nails. Common wire nails, box nails, and sinker nails have smooth shanks. There are other types of nails known as deformed nails, which have ridges or spiral formations along their shank to increase their grip in wood and reduce the likelihood of pulling out over time. Before looking at an example to illustrate the differences in strength between 8-penny common nails and 8-penny box and sinker nails, let us look at item 31 through 33 to see what the code actually says. First and foremost, it is important to note that our discussion is limited to conventional construction as opposed to engineered design, where the design engineer is not restricted to the prescriptive provisions in the IRC. Therefore, we are considering the application of the code with respect to structures designed to conform to the conventional construction provisions in the 2024 IRC. The fastener requirements shown on item 31 through 33 of the fastening schedule in the IRC apply to wood structural panels such as plywood and OSB used at the subfloor, roof, and interior walls. The fastener requirements also apply to wall sheathing attachments using particle board sheathing. For wall sheathing attachments at exterior walls, the Residential Code references Table 3 in Section R602.3. This table only specifies common nails and does not provide options for sinker and box nails of the same size designation. Item 31 in the fastening schedule provides nailing requirements for wood structural panels that are between 3/8 to 1/2 inch in thickness. For subfloors and wall connection, the code allows 6-penny common nails or deformed nails of the same size. The code does not allow 6-penny sinkers or box nails, but it actually allows 8-penny sinkers, which are 2 3/8 inches in height by 0.113 inches in shank diameter by 0.266 inches in head diameter for subfloors and wall framing. For roof framing with sheathing not exceeding 1/2 inch sheathing in thickness, the code only specifies 8-penny common nails or the RSRS01 nails. RSRS stands for Roof Sheathing Ring Shank. The roof sheathing ring shank nails are specifically designed to enhance the attachment of roof sheathing, particularly in areas prone to high winds. These nails feature a ring shank design, which provides superior withdrawal resistance compared to the smooth shank nails. Just like item 31, item 32 and 33 also either allow common nails or either roof sheathing ring shank nails or deformed nails depending on the connection. The point we are making is that sinker nails and box nails cannot be considered in the same capacity as common nails of the same penny size designation, especially in roof sheathing attachments where the code hardly offers any alternatives using box and sinker nails. That being said, there are some cases where the International Residential Code allows galvanized box nails of the same size designation as the common nails specified. This includes wall bracing methods such as alternate braced wall, portal frame with hold-downs and portal frames at garage openings where the code in section R602.10.6 requires 8-penny common nails but also allows galvanized box nails. Additionally, the code also allows galvanized box nails in lieu of common nails for continuously sheathed portal frames in the same code section. Let us now look at an example to illustrate the differences in design strength between 8-penny common nails and 8-penny box and sinker nails. As we have seen, common nails are wider than both sinker nails and box nails and longer than sinker nails. These properties also translate to superior strength for common nails when compared to the other nails. We will look at the strength of 8-penny nails attaching sheathing to wood framing. This example is intended to illustrate the importance of ensuring that designers call out the proper nail types according to the design tables in the Residential Code. Additionally, the contractor must use the nail types specified by the designer. The design values for nails in wood construction are provided in the National Design Specification for Wood Construction. This specifications may be purchased from the American Wood Council or freely viewed from their website. According to Table 12R of the National Design Specification for Wood Construction, the reference design values for nails attaching wood structural panels to wood members in single shear are as follows. For this example, we are using 15/32 wood structural panels. 8-penny common nails have a reference design shear strength of 65 pounds. 8-penny box and 8-penny sinker nails have a reference design shear strength of 50 pounds. These reference values for single shear are based on nails penetrating at least 10 times their diameter into the main member. In this case, the stud is the main member, and the sheathing is the side member. Therefore, using an 8-penny box nail instead of an 8-penny common nail for cases where the code specifically requires 8-penny common nails means that the shear strength of the connection will be undermined by about 23%. This means that the designer must clearly specify the type of nails that are required to be used on a project, and the contractor must use the type of nail specified. Therefore, as we have seen, the type of nails that you use in residential construction is neither a trivial issue nor a mere afterthought. This is a critical factor that must be deliberately considered and specified in the construction drawings to ensure code compliance and structural integrity. Additionally, the contractor must ensure that the nails used in construction are consistent in type and size to the nails specified on the construction drawings. It is important to note that nails are just one element in a much larger system. Designing and building a fully code-compliant wood-framed home is like conducting an orchestra. Every element from roof and wall framing requirements, floor and deck framing requirements, wall bracing requirements, concrete and foundation requirements to the protection of lumber against decay and many other considerations must work in perfect harmony. If one part is out of sync, the safety and well-being of the occupants may be compromised. As a designer or contractor, you're the maestro and must ensure that every component comes together seamlessly to create a home that is strong and safe. That is why we have created the Residential Wood Framing Design Series. This step-by-step program takes you through the process of designing and developing the drawings of a 2-story home using the prescriptive provisions of the International Residential Code. We take a deep dive into the code and emerge on the other side with the structural design of a 2-story house and armed with enough knowledge to build a reputation. You will learn how to design and document an entire structure from the roof, the floors and decks, walls and foundations, as well as wall bracing while ensuring compliance with the International Residential Code. If you're a contractor looking to streamline your workflow, a designer wanting to master residential wood framing, or a design enthusiast planning your own project, this course is for you. Nearly all states permit all individuals to design 1- and 2-family wood-framed buildings using the conventional framing provisions in the International Residential Code, even if they are not licensed as structural engineers or architects. Click the link in the description to learn more and start designing with confidence. Thanks for watching, and if you found this video helpful, be sure to like, subscribe, and stay tuned for more insights into wood framing.